This is the advanced functions lesson on factoring a sum or difference of cubes. So before we get to that, let's review how to factor a difference of squares. Remember that the numbers or the terms that go inside the brackets are the square roots of the original terms. So let me just set up a set of brackets here. We're going to factor this. This is review using a difference of squares. So we set up two sets of brackets. One set has a plus sign and the other has a minus sign. It doesn't matter which is which. At the front of both brackets goes the square root of the first term, the square roots of the original term. So this is going to be a 2x at the front of both sets of brackets. At the back of the brackets is going to be a 3y to the power of, we take half of this power, we divide that power by 2, so the power of 3y to the power of 3. So this is the same process we're going to use for sum or difference of cubes. Just notice in the original question here, we only had a subtraction sign in the middle. We just did a difference of squares. So we're going to do a difference of cubes, but also a sum of cubes. There are formulas for difference of anything. Difference of squares, there's your formula. Difference of cubes, this is what we're going to talk about today. And we can do difference of quartics and so on, all the way down to difference of any power. If you have something to the power of n here and the same power as here, you could have this very complex looking problem. But we're only going to do difference of cubes. The degree you'll see most often in this chapter is 3, cubic. So you need to memorize this formula for factoring a difference of cubes. It's pretty straightforward. Since this is a subtraction sign, we want a subtraction sign here, and then we have two addition signs and the squares here. Let's figure out some examples here. Example 1, factor, don't simplify. So I'm saying don't simplify because I don't want you expanding that power of 9 out and then collecting like terms. We want to factor. So we need to first identify this as a difference of cubes. So we've got the difference sign in there, the subtraction sign, that's important. Let's look at this 1/8 first. Is 1/8 a perfect cube? Because it has to be a perfect cube in order for us to use this little formula here. So is 1/8 the perfect cube? It is. The cube root of it is 1/2. Is this a perfect cube? It is. Doesn't matter that this plus sign is here or this is a power 2 or a plus 2, those have nothing to do with cubes, but that entire bracket has a power of 9 and we can take the third root of that. So the first thing that we're going to do is just identify, since our formula has a's and b's in it, let's identify what the a's and b's are. So the a is equal to the third root of your first term. So that's the third root of w squared plus 2. I'm not actually factoring yet. I'm just kind of getting set up. This is an aside here. So the third root of w squared plus 2 to the power of 9. So remember that that's the same as writing w squared plus 2 to the power of 9. Sorry, square bracket there. To the power, all to the power of 1/3. So that's the same as a cube root. So I take these two exponents and I multiply them together and they're going to turn into a 3. That means my a value is w squared plus 2 to the power of 3. So that's what I'm going to sub in here. I'm going to underline at the top. Everywhere there's an a, I'm going to sub in w squared plus 2 to the power of 3. So we'll do that next. Now let me switch colors and let's figure out what b is. b is equal to the third root of our second term, which is 1/8. So not negative 1/8. Don't worry about the sign, just the term that's in the second part of the binomial. So the third root of 1/8 is 1/2. So now that we know what a and b are, so everywhere I have a b up here, I'm going to be replacing that with 1/2. So now I can go up to my question. I'm going to just go to the side of it here. Normally I would go directly underneath, but I took up all my space. So that's equal to, so this corresponds to these pieces here. Now this is my equal sign. So my first bracket is a minus b. So a, let me just highlight it for you here. My first bracket is a minus b. So I'm going to write a minus b. My first bracket is, I'll use the same colors, is going to be w squared plus 2 cubed. That's the A, minus, and then B. And my B value is 1/2. 1/2 goes there. Oh, I switched green, so that's okay. Let me fix that. I'll go back to the right color. All right, that's better. So that's just A minus B. That's all that is right there, is A minus B. Now I need another bracket. So this is just A minus B. Now my next bracket has to be A squared plus A times B plus B squared. I'll erase this in a minute here. Plus B squared. So that's what's going to be in my second bracket. Let's start with the A squared. A, remember, is, so I'll open another bracket. A is W squared plus 2, and that's got to be squared. The next thing I'm writing is plus A times B. So back to the A again. Sorry, the first one is A squared. This is cubed, but then I have to square that whole piece. So I need to get rid of that. I need to square this whole thing. There's my A squared there. There's the squared, that's a cube there. Now I add on A times B. A is W squared plus 2 cubed times B, and B is 1/2. Multiplying. Then I add on B squared. And B squared is just going to be 1/2 squared. 1/2 squared. And that's my whole second bracket. So I've intentionally started with a complex example of difference of cubes, because if you can follow me with what I'm doing here, then you're going to be good to go with the easier ones. And most of them are easier than this. There's some that are harder, but I'm starting with the hard one on purpose. Okay, so what's our next step? We do have to simplify those brackets if we can, but we're not going to expand. We're just going to simplify little things like 1/2 to the power of 2, that sort of thing. So I'm going to leave my bracket here, and my A is the same. W squared plus 2 cubed. I'm not going to expand that out and figure out what it is. Minus 1/2. There's my first bracket. My second bracket is W squared plus 2 to the power of 6. So I'm going to put these two together. W squared plus 2 to the power of 6 plus, and the only thing I'm going to do here is take the 1/2 and move it to the front, because it's the number itself is like a constant. There's no variable with that 1/2 term, so it's going to become a coefficient. 1/2 bracket W squared plus 2 cubed. And then our final piece, we can turn that into a 1/4. 1/4. So that is all I wanted to do for that example 1. That's the factored form of that kind of complicated question. Now, when I go ahead, example 2 is going to show up underneath all this handwriting, so I'm going to erase the handwriting. Let's show you what I mean here. There's example 2, so I'm going to have to erase to make some space for myself here, I think. Well, let's try it. Let's see if we can, maybe I can just erase some of this stuff. Yeah, so we'll try it without me having to erase all that. If I switch colors, maybe that'll keep it okay. Factor completely 1 minus x to the power of 6. So we're going to factor it as a difference of squares. So I'm going to first, up at the top, I'll identify what my A value is. My A value is the third root of my first term, which is a 1. So that's easy. A is 1. My B value is the third term of my second part of the binomial, which is x to the power of 6. So remember that's going to be 6 divided by 3, so that's going to be an x squared. So now I know my A and I know my B. So I will sub into the formula. I'm going to move down a little bit so there's some more room. I think I'll start over here. So looking back up to our formula, I'm going to start with this bracket, a minus b. A minus b is simply 1 minus x squared. Look up here to see what the a and the b are. The next part, the larger part here, open another bracket and I start with a squared. A squared is 1 squared. A times b is next, and that's going to be 1 times x squared, which is just x squared. And then b squared is, let me write it out, b squared is x squared squared. So cleaning that up, we get 1 minus x squared times 1 plus x squared plus x to the power of 4. So one thing you may notice here is we've got a difference of squares right here. This is a difference of squares, so we can factor that a little further. Equals 1 minus x, 1 plus x. And then our trinomial is 1 plus x squared plus x to the power of 4. And you'll notice I said trinomial there. Does this fit our trinomial pattern that we've talked about in a previous lesson, this last bracket? It does. It has, you could rearrange it if you wanted to, but we've got our x to the power of 4 here, we've got half of it here, and we've got none of it here. So this is a trinomial. So you could try to factor it. Is there anything that we would rearrange it first? Is there anything that multiplies to 1 that adds to 1? No, but you could also try the factor theorem here. If I rearrange this, let me just write it, I'll write it off to the side of the grid. If I take just that bracket, so that bracket is 1 plus x squared plus x to the power of 4. So I'm just going to rewrite it in order. It's always more helpful to look at it like this. X squared plus 1. So this piece, I want to see if I can factor it further. Factor theorem is the plus or minus p over q. And in this case, that would only give us plus or minus 1. So I could try to sub in positive 1 or negative 1, but none of them are going to work. So we're not able to find any more factors from that one. So the question said factor completely, but with the skills we have, which is a trinomial factoring of this, or the factor theorem, we haven't got any more factoring we can do. The last part of the same question is down at the bottom. It says, for example, to state the zeros. The zeros are the zeros that we got. So this bracket gives me x equals 1. This one gives me x equals negative 1. This one doesn't give me any. I get none from there. So the zeros are x equals 1, x equals negative 1. Use the zeros, the degree of the polynomial, y, everything like this, and we're going to sketch a graph. So now that I have the x-intercepts, they're at 1 and negative 1, I know what to use a scale for my x-axis. I'm going to spread it out. This is a tiny grid here, so I'm not actually going to count by 0.5s here, but I'm going to label every second one. So actually, let me press pause here, and then this won't take so long. So again, I'm looking at example 2. I'm going to highlight this. So we're going to let that equal f at x. We're going to turn it into, it was just an expression, but we're going to turn it into f at x equals that. And what I want to do is figure out what the y-intercept is going to be. So this is equal to f at x. So let's put those values on, and then we're going to look at the y-intercept and get a scale for the y-axis. So I have an x-intercept at negative 1, and I have an x-intercept at 1. The next thing is to get something on my y-axis here. So I have a, if I look up to the original equation, sub in a 0 for x, and we get 1. So we have a y-intercept of 1, which means I can use the same scale I did on my x-axis. I can count by 0.5s. And here's my y-intercept at 1. So let's go back down and look at the question. So state at the bottom here, state the zeros. We did that. We use the zeros. Now we use the degree. The degree of the polynomial is a 6, so that's even. So that means it's going to behave like a parabola, meaning the end behavior, both ends are going to be opening up or both ends are going to be pointing down. So how do we figure that out? That's the leading coefficient will tell us that. Our leading coefficient is what's in front of our highest degree term here, and since what let me write it here, we have negative x squared, negative x to the power of 6, our leading coefficient is negative. That means it's going to open down, and our end behavior is going to be as x approaches positive or negative infinity, so it's like a parabola, remember, our function is opening down, our y's are approaching negative infinity. So both ends are going down. We've got the y-intercept, and we're going to use all of this information to sketch a possible graph. So all I have here are these 3 dots, and I know that it opens down. So I'm just going to connect them like a quadratic, but I'm going to make it flatter since it's a power of 6. Now you don't know, there could be other kind of maybe turning points in here. Well, there's not, but all we can do is use the information that we can get at this stage. So we're just going to draw, whoops, that shouldn't curve backwards like that. It should be curving, going straight down and kind of flat here and coming around and going down. So that's a possible graph of f of x equals 1 minus x to the power of 6. Next question is factoring a sum of cubes. So we've only talked about the difference of cubes so far. There's also a formula for the sum of cubes. When you have a perfect cube and then you're adding another perfect cube to it. So it's a little different. Students often get these mixed up when they have to memorize the formula. So this one has a plus sign in the binomial, just like this sign here is plus, and then these are negative and positive. But the a, b's, and a squareds and b squareds, that's all the same. We're going to factor to determine the x-intercepts. So this right now does not look like perfect cubes. These individual terms here are not perfect cubes. We've got a power of 5 here and a power of 2, and we've got numbers that aren't perfect cubes. But what I do know, the very first type of factoring I should always look for is a greatest common factor. There is a greatest common factor here, and it is 3x squared, but I'm actually going to factor out a negative 3x squared so that I don't have to worry about all those negatives in there. So factoring out a negative 3x squared leaves me with, so you can get out your calculator, this is 125 x cubed plus, remember I factored out a negative, plus, and then this is a 64. So what I have now in the brackets, that's a sum of cubes. So I'm going to do the same thing that I've done before. I'm going to kind of write off to the side here what my a and b are so that I can fill in the formula correctly. So a is going to be the third root of my first term, 125x cubed. So a is 5x. B is going to be the third root of my second term, which is a 64, and the third root of 64 is 4. So now we have our a's and b's, and we can just go ahead and sub into the formula. That first factor that we've taken out, the negative 3x squared, that's done. That's great. You're getting a mark for that. Leave it there. Don't put it back in, and don't ignore it and drop it off. That is a piece of the factoring pie, so please don't decide that you don't need it anymore. Now we're moving up to the formula. So let me just highlight this. 125x cubed plus 64, that's this side right here. That's this piece, a cubed plus b cubed. This is a cubed plus b cubed. So now I'm going to rewrite that all with this instead. So my first bracket is, first thing I'm going to put in, I'm doing this piece right here, is a plus b. So my A is a 5x and my B is a 4. So that's the first part. Now I'm going to do the second bracket. So I start with an A squared. 5x squared is 25x squared minus A times B. So I've got to multiply these two together here. A times B is going to give me 20x. And then plus B squared is 16. So look at our original question again. It said factor to determine the x-intercepts. So have we finished factoring? Well, the monomial is good at the front, the negative 3x squared, that's done. This bracket can't be factored any further. It's linear, there's no powers here, there's no greatest common factor. But maybe this one can. So remember, if you're working with a quadratic like this one, you already have strategies for that. So this is the power of 2, so we can factor this or use the quadratic formula. So we have a power of 2 here, so you could have done this for me in grade 10. If I just gave you this piece and said factor, or no, said find the x-intercepts, find the x-intercepts, you would hopefully know to factor or to use a quadratic formula. But one other thing I want to talk about here is the discriminant. What does the discriminant tell you about the nature of the roots? Checking this can save time, so let's talk about the discriminant right here. Discriminant, remember, is, I'll put it underneath, the formula for discriminant is b squared minus 4ac. And that's the part that's under the radical sign of the quadratic formula. So let's just sub in here. Rb is a 20, it's a negative 20 squared, minus 4 times 25 times, I'm running out of space here. Okay, sorry, I just moved that over so it would fit. So our discriminant, negative 20 squared, is 400. Minus 4 times 25 times 16 is minus 1600. That gives us negative 800. So what does this tell us if we have a negative discriminant? Remember, the discriminant comes from the formula, the quadratic formula. It comes from this part right here, b squared minus 4ac. So I could have done the whole quadratic formula, but just doing this alone right now lets me see that I'm going to have the discriminant tells me it's going to be a negative. So that means there's no solution. We will never be able to find any more zeros or roots for this last bracket, this last red trinomial here. That's what my discriminant tells me. And I could have gone right to the quadratic formula and thought, well, I can't factor this, it's taking me too long, and I try the quadratic formula. As soon as I got to this piece, I would see, well, I can't go any further. So sometimes it's faster just to check that first, as soon as you know the nature of the roots. So if we would have got a 0 under here, if this would have been a 0, it means that we could have factored it, but you can still use a quadratic formula for that. If you get a number that is a perfect square, it means you could have factored it if it works out nicely here. But if, more importantly, if it's positive, it gives you 2 roots. If the discriminant is positive, you're going to get 2 zeros out of the quadratic formula. If the discriminant is negative, you're not going to get any zeros. And if the discriminant is 0, you're going to get 1. So checking this can save time. So we will never be able to get any roots from these. And this whole formula, a squared minus a times b plus b squared, if you use those letters and sub them in, or numbers and sub them in, it's always going to be a negative. So it's good to check that. So all that we really do have from this question, remember the question said determine the x-intercepts. So we've got an x-intercept here when x equals 0. There's one x-intercept. This x-intercept is when x equals negative 4 over 5. And these are both linear or straight through roots. They're just going to cut straight through the x-axis at those 2 points there. We didn't have to sketch a graph, but I'll just show you quickly. And I always recommend putting Desmos on your phone or having the tab open. I use Desmos all the time. If I did a quick sketch of this, oops, I would be coming, sorry, this one's a bounce. I don't know why I said that. This one's a bounce right here. Right? This one's a bounce because of the power of 2. This one is linear. So that means when x is 0, we're going to bounce. Here's, let's say that's -1, and that's +1. My graph is going to bounce. It's a power of 5. My degree is 5th degree, so we're going to have one end up, one end down. My leading coefficient is negative, so it's going to start in this quadrant and it's going to end in this quadrant because it's overall decreasing, it's going down. So I'm going to start here, come down, cut through 1, and then it's going to turn around somewhere and bounce at 0 and come back down again. So that's kind of the shape of what you would have there for that question. All right, we're almost done. We have one more example. We're going to start first with the formulas. The difference of cubes, this one, and the sum of cubes. Very similar, don't confuse them. Example 4, factor and simplify. So look at your look at your equation here. This is a perfect cube. The power is 3. That's the easiest way to tell. This is a perfect cube, and we have a plus sign. So again, it doesn't matter what's inside the brackets. Nothing in here is a perfect cube, but this power means there are 3 of these brackets. So that's why it's a perfect cube. So what we have to do here is factor and then simplify. So let's start with identifying what a and b are. A is going to be the third root of my first term, and my first term is x plus 4 cubed. So a is simply x plus 4, because the power of 3 and the third root will cancel each other out. B is the third root of my second term, 3x minus 1. So b is simply 3x, sorry, that's cubed, 3x minus 1, because the cube root and the cube cancel each other out. So that's our a and our b. Now we can go up to the formula and sub into the sum of cubes formula. So I need lots of space for this because I've got binomials all over the place. So the first thing I write down is a. And a is, I'll use square brackets on the outside, a is x plus 4. That's this that I just did here. Next is plus b. Plus b. That's plus 3x minus 1. So there's my first bracket set done. Now we go to the second bracket set. So now I need a squared. Okay, my a is x plus 4, so I'm just going to put a square on that, minus a times b, so I'm going to put my two brackets together, x plus 4 times 3x minus 1, and then plus b squared, so that's 3x minus 1 squared, square bracket. So the question said factor and then simplify. So we have factored it. We've done the first part, but we have to simplify it now. So here's where we just are collecting like terms. In my first bracket, this is a plus sign, so I'm just going to drop the brackets. I have an x and a 3x. That's going to give me a 4x. So let me just open a new bracket here, 4x, and then my constants are 4 minus 1, that's 4x plus 3. So there's my first bracket, that was easy. My second bracket is not as simple. First I'm going to expand x plus 4 squared. X plus 4 squared is x squared. So remember x plus 4 squared, look at the top, is x plus 4 times x plus 4. We should be able to all do that in our heads right now. But if you can't, okay, the answer is not x squared plus 16. So it's going to be x squared plus 4x plus 4x plus 16. So I was just going to jump to the answer here. That's x squared plus 8x plus 16. That's just the first bracket there, the first piece. Now I'm going to subtract. I have to be careful with my subtraction because I have to subtract those two factors once I multiply them together. I'm going to put another bracket up so that I don't mess up my signs. So I'm going to distribute here. X times 3x is 3x squared. X times negative 1 is negative 1x, and then I'm going to do this at the same time. Negative 1x plus 12x. Negative 1x plus 12x is plus 11x. And then I have a minus 4 for my last pair there. And for my last binomial, so again it's squared, you're going to have to write it out twice. I'll put it up above here again. 3x minus 1 times 3x minus 1. You can't just make it 9x squared minus 1. If you're thinking that, that is a grade 10 error. You should not be making that error now. I will show you the distribution. You should get 9x squared minus 3x plus 1. So here in my bracket, I'm going to drop the bracket because of this plus sign. I don't need to be careful. This will be a 9x squared minus 6x plus 1. So we're going to clean it up a little bit more. 4x plus 3. And I'm going to do 2 steps in one here, which you guys should all be capable of doing. I'm going to start with the x squareds. I've got this x squared. This is going to be a negative 3x squared, and then plus 9x squared. So x squared minus 3x squared plus 9x squared. That's going to be a 7x squared. Now let's look at the x's, single x's. We've got 8x, and that'll be a minus 11x. Remember this negative sign here? That'll be a minus 11x minus 6x. So that's going to be minus 9x. And now our constants. Our constants, we have a plus 16. This will be a plus 4, and plus 1 make 21. Close the bracket. Now we have simplified. So once we've simplified, we always take another check to see if it can be factored any further. Can this quadrat, the first piece cannot be factored any further. The 4x plus 3 is a linear factor. It's all done. What about this one here? So we're going to check the discriminant again and see. The discriminant would be b squared minus 4 times a times c. So you do all of that work and you get negative 507. It's negative again, so we can't factor any further. So that's as far as it goes. So that's the end of that one. So this one would be, if we were graphing it, we don't have to, but I'll just throw some more important information your way. If we did have to graph it, we would know that the degree is cubic, and we can get that from originally up here. The highest degree, even this is addition, so we would be expanding all this and everything, we would get a degree of 3. So we have an odd degree. That means opposite end behavior, one end up, one end down. The leading coefficient is positive, and you can tell that by looking at if you had all these x cubes and you had all these 3x, 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 27x cubed, you put them all together, you've got a positive leading coefficient. So it would be having this kind of shape here, starting down, maybe curving around a bit and going up because its leading coefficient is positive and it's cubic. And it's got 1, 0, just this one here, so it's only crossing once. So that's all the information we can get from that question. What you should do, as I've recommended, is go to Desmos, type in the original expression, type this in, and then type this in. If it was done correctly, the graphs will be what? What will you see on Desmos? You're going to type this into one equation box, and then underneath you'll type this into another graphical equation box. What do you think you will see on your graphs? Well, they should be the same. They should be exactly the same. That's how you can check your work too. And there's a scale on Desmos, so you can adjust it, because this particular one, we're going to need our y-axis is going to have to go up really high and down really low, so you can change your scale. But I suggest you try that with this or with any questions in your homework. If you think you got it right and you tried a question, you did all the work, you can't find your mistake, you look in the back of the book must be wrong because I'm pretty sure I'm right, well then check with Desmos. Sometimes the back of the book is wrong. So check with Desmos, put them both in. You should get the same thing. Desmos should be your favorite app on your phone. That's the end of the lesson today. Last thing, there's a textbook mistake, or there's lots of textbook errors, so I have posted a textbook errata for a textbook which has pages and pages and pages of mistakes in the textbook. So do check those to make sure when you get an answer like this and you think you're right, but it's not the same as at the back of the book, check the errata and check Desmos so that you don't get frustrated. Good luck with the homework.